Hey everybody, this is Larry. This is March 11th of whatchamacallit, 2025. This year's great. Crazy. But yeah, hit the like button, the subscribe button, join me in Discord. Let me know what you think about today's problem. I'm doing a bonus extra problem because, well, we had a easy problem for the daily problem, so I just want to do a bonus one. Feel free to do it with me, though. I try to do one that I haven't done before. Why does this look so weird? Is it just me? Something feels off about it. Anyway, yeah, let me know what you think about this one. Apparently I haven't done this one yet, so let's see. I have 1081, smallest subsequence of distinct characters. Given a string S, return the lexicographically smallest of S that contains all distinct characters of S at least once. Oh, small subsequence. But it has to be lexicographically smallest. Okay. Distinct characters. Okay, I mean, yeah, I mean, I think for these lexicographically smallest problems or whatever, the first thing that I would think about is the first thing that comes to my mind rather is that it's going to be, I don't know. I hesitate to say greedy. It's like a weird sort of greedy and brute force, right? It's not brute force in that you try every answer, but you brute force on every digit, right? On every number, on well, I say a character, sorry, right? And here you know what the final answer has to be, right? In that there are at most 26 characters, right? So then the question is, so the question you want to ask one character at a time is can the first character be an A? No. Can the first character be a B? Yes. Okay, let's go to the second character. Can the first character be an A? ... right? So if you're able to kind of do that, then you can get the answer. And then the rest of the problem will be just try to figure out how to set up your data structure so that you can answer that very quickly. And I don't think that it's too bad. You could probably there are a number of ways you could do it. We could do it with variations. I think you can do it with binary search. You can do it with a queue, or yeah, I think there are a couple of ways to do it. Can I do it with? Maybe binary search is the easiest. Okay, so the way that I would structure it is something like this, right? So n is equal to length of s, and maybe we have a set of s. Maybe m is equal to this, or length of this, because this means that, okay, maybe we just have also s is equal to just a set, and then, yeah, because we probably need the set, I suppose. Doesn't really matter that much, I don't think, because you're only outputting 26 characters anyway, so 26 square versus m square is not that much of a difference for such a small number of m, so I'm not going to do it that I'm not going to do it m sensitive, but we can if we want, right? Yeah, and then it's just literally okay, so we start with an answer, right? And maybe like used is equal to set, so that we can mark the characters we have already used. And then now it's just for I in range of m, so we want to create the characters one at a time. We want to try literally just for C in, there are a number of ways to write this, but you could today I want to write what's it, ASCII lowercase. I always forget it. Let me see, it's either lowercase ASCII or ASCII lowercase. That's why I always have to double check. My memory is old and I've forgotten. Okay, so that doesn't throw an error, so that means that's good, right? So then now can we do this, right? So if C is not in use, that means that we can, but then now we have to do a check, right? So then now I think one thing that I didn't keep track, right, is that what is the first character that we can do, right? So here, oh, I didn't do a lot of things, I just forgot. So first thing I want to do actually before that is that we want to do index C and enumerate S. So we want to kind of go through the string and pre-process it so that yeah, I mean, I'm going to write it this way just because I'm lazy. You can actually make them into arrays if you prefer, but f of c append index, right? So then the two things that comes out of this, that means that for every character, we want to keep track of the indexes in a list of lists, right? So, or a map of list more precisely, but yeah, right? And of course, because we're going through this string in order, everything in here is going to be in order, right? Which allow us to do binary search, which we kind of spotted before. And then now when we add a new character, we want to say maybe, yeah, maybe you can say like previous is equal to, is previous the right word, character? I don't know, right? But just like as a bound, right? And what I mean by that is that, well, you'll see in a second, all right? Basically, it's just when you look at S, that's the character in which you cannot use anything before, right? For example, we have BC, ABC. If you put an A in the front, which is fine, but that means that you cannot use these previous characters. So when you search, you have to go to the right of the A. That's basically it. I don't know if this is maybe I don't know. Naming things is hard, so I'm just gonna call it prev because it reminds me of like the previous thing that with previous boundary or something like this, right? So yeah. So then here, if C is not used, then let's see if yeah, we can binary search, right? So f of C is an array. It has indexes of indexes of all the character or the C's or the character variable character C, right? So then we want to bisect that to the previous, right? This pre variable, so that because that we want to see the first instance that that we are able to, right? So here's the index, right? If index is equal to, excuse me, if it's equal to n, oh no, not n. If it's equal to left of C, right? I like to write greater than equal to because it's the same thing. Or, I don't know. But yeah, if this is the case, that means that it doesn't exist, and then we can just continue because we cannot use this character anymore. You could actually even put this in used, maybe, I don't know, because not, you know, it won't get higher, right? It won't get lower rather, so you have to skip it. And then next, then, right, is that yeah. So then now we have the index, right? So it gives us the index, and then yeah, character index is equal to this. So this means that this is the character of the next C that exists, and then now to see whether whether we can add C in as the current index, we will have to check all the other characters to see that they still exist, or that of course we're done, right? Yeah. So then here, maybe maybe I should have to, I don't know why I wrote it this way. Maybe I could just, the reason why I want to write this way is because it's sorted. Otherwise, you have to sort this, which is maybe fine, honestly. But yeah, but here then, and we have to say for, I don't know, n for the next character, and C for next character, maybe. In the set for each character, if C is equal to NC, we just continue because it's fine, right? So we have a good is equal to true, because here we you know, this is just a character we're processing. Otherwise we also do a binary search, right? We binary search left of f sub nc. We want to search for C index and see if it exists, right? So if this is greater than or equal to f of nc, or length of that, then good is equal to false, because well, yeah, okay, we have to kind of, I have to update s. I think that's why I'm gonna, because you have to maybe if not used, right? If nc not in used, and this because basically if it's not used but it is missing, then good is equal to false, right? So if it's true for all the other characters, meaning that it's either used, or if it's not used, there's a character in the future, then now we can say, yeah, answer, we append C, right? We set previous is equal to C index plus 1, because you want to burn up the current index. Though I guess it doesn't really matter, because we also just do used. we want to add C, so we don't repeat the character for this problem anyway. And then at the end, we just join it by the answer. And that's it, hopefully, if I'm right. I mean, I could be wrong. A lot of easy typos. And yeah, let's give it a submit. Oh no. Oh no. Am I off by one? On the... That doesn't make sense. There are 2 E's. Oh, that's silly. The reason why I this is wrong, and I meant to do this, but then I guess I forgot. But yeah, here we actually want to break out of this loop, because what happens is that this loop was true for L and then T, and then before it goes back to the next I, and it just so happens that that is silly. I am a silly boy. Yeah, you could see. Yeah, what? That's a okay. Oh well. Silly mistake, Larry. But yeah, that's all I have for this one. Yeah, so for the most part, here this is linear, right? We just go through all the characters once. And here, this part is O of M, as we said. This is O of alpha, but keep in mind that M is also limited by alpha. So you could say maybe this is M times alpha, right? And then, yeah, M times alpha. And for each of these things, we do a binary search. This binary search is actually on N, right? So, so yeah, so it's log N. Yeah. And then there's another one here, right? So yeah, so basically this is M cubed log M, or log N, sorry. So yeah, that's pretty much it. Let me know what you think. Yeah. There are probably other ways to do this, but I don't know. I think this is the most straightforward to me, even though I did make a mistake. I guess the most straightforward way is look at this one. Did I do that one? How did past that? Oh, apparently I did do this one. Okay. I mean, basically I did the same thing. Maybe the code is a little bit cleaner. I don't know. All right, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good. Stay healthy to good mental health. I'll see y'all later and take care. Bye bye.